Hey everyone, and welcome to This Explainer. Today, we're diving into a massive shift in how modern businesses actually handle their IT environments. Look, we all know that in a fast-paced environment, trying to scale your IT infrastructure manually is a painful, everyday reality. Consumer demands are growing, traffic is spiking, and speed is absolutely of the essence. And yet, so many engineering teams are still just bogged down by the sheer weight of managing physical and virtual network infrastructure by hand.
So, I gotta ask, are you or your team still logging into devices manually? Because let's validate that pain for a second. We all know the nightmare of late-night troubleshooting, right? The constant anxiety of deployment failure. Just picture a highly skilled developer or network engineer logging into a management console, clicking through endless drop-down menus, and manually spinning up virtual machines, firewalls, and load balancers. I mean, sure, it might feel powerful for one account, but what happens when your boss asks you to replicate that exact setup across 99 other accounts? It is a recipe for disaster. One misclick, one forgotten parameter, and suddenly your entire infrastructure is compromised or just outright broken.
43. That staggering number represents the hours a team of engineers could easily waste every single year just spinning up virtual machines manually. Just think about it for a second. If it takes just 1 minute to launch a VM manually, and you do that every business day, well, that's 260 minutes a year. But if you have 99 colleagues doing the exact same thing, that balloons to roughly 43 hours annually, literally just clicking buttons. That's essentially an entire week of human capital totally lost to a task that could have been completely automated. Okay, here's our roadmap for today. First, we'll look at the manual configuration trap. Number 2, what is infrastructure as code? 3, consistency and repeatable deployments. 4, auditability and change control. And finally, number 5, safer changes and rollbacks.
Section 1. The manual configuration trap. So, when engineers rely on manual setups, it inevitably leads to a really dangerous concept, the snowflake device. This happens when intended identical devices suffer from configuration drift. Because think about it, if you were given 2 hours to roll out a brand new site by hand, setting up firewalls, DMZs, switches, virtual interfaces, it is highly likely you're going to make a mistake. Because human beings are doing the manual typing, inevitable human error leads to undocumented, totally unique configurations. If you ask someone to manually deploy 1,000 virtual machines, I don't care how careful they are. Those 1,000 VMs will not be set up the exact same way. A typo in a config file here, a missed software package there, and suddenly troubleshooting becomes an absolute nightmare because every single device is beautifully, frustratingly unique.
Section 2. What is infrastructure as code? Let's directly contrast the daily nightmare of manual configuration against the streamlined, reliable nature of an infrastructure as code environment. Manual setup, it's error-prone, it's incredibly slow, and it often relies on siloed knowledge locked inside the brain of one specific engineer. But on the flip side, infrastructure as code is completely automated, infinitely scalable, and entirely version-controlled.
So, getting to the actual definition. Infrastructure as code, or IAC, is the process of provisioning and managing your operational environment using machine-readable definition files. Instead of relying on a human to configure tools or physical hardware, you actually define your baseline rules, like your subnets, your open ports, your encryption standards, straight into code. And because this code is machine consumable, you can run it across multiple accounts, deploying identical infrastructure without ever having to touch a web console again.
Section 3. Consistency and repeatable deployments.
Look, there's an old golden rule in IT that we should honestly all live by. If you have to do it twice, you should automate it. By taking the time to write reusable code templates up front, you completely eliminate those snowflake devices we talked about a minute ago. You write the code once, and then you just reuse it over and over again for your development, QA, and production environments. It cuts out the repetitive, boring work and frees up your highly paid network engineers to focus on what matters: actual design, validation, and complex troubleshooting.
Let's put this into perspective. Imagine a fast-growing e-commerce website. At normal traffic levels, say around 10,000 users, your infrastructure code automatically provisions 100 containers to handle the load. But suddenly, there's peak demand, like a massive holiday sale, and traffic spikes to 100,000 users. Your IAC tools, using predefined business logic, just seamlessly scale up to 500 containers. But what's equally awesome is what happens post-peak. When the users drop back down to 50,000, your code identifies those idle resources and dynamically deprovisions them. Which means you aren't paying your cloud provider for unused resources. You're ultimately saving the company a massive amount of money.
Section 4. Auditability and change control.
Because your infrastructure definition files are stored in a version control system like Git, Azure repos, GitHub, or GitLab, every single change is meticulously recorded. You get the exact metadata of what was changed, who made the change, when it was made, why it was required, and who reviewed it. This completely solves the problem of siloed knowledge. If your lead cloud engineer takes advantage of that unlimited vacation perk and drops off the grid for a month, it's genuinely no problem. The rest of the team can just read the Git history, understand the existing state of the infrastructure, and confidently make any necessary changes.
So let's walk through this structured Git workflow to see exactly how peer review happens long before a change reaches production. First, an engineer creates a working branch. Second, they update the infrastructure code to reflect the new networking needs, drastically reducing the manual effort for routine tasks, like maybe updating an access control list or deploying standard VLANs. Third, team members review the proposed changes and approve them through a pull request. And finally, the approved configuration is applied and the deployment is validated. This guarantees that any errors are caught by peer review before they ever touch your live production servers.
Section 5. Safer changes and rollbacks.
When you treat your infrastructure as code, you get to take full advantage of the DevOps shift left mentality. Now, shifting left just means detecting and fixing issues as early as possible in the development pipeline, rather than waiting for things to break in production. Your automated workflows can actually perform syntax validation, configuration comparisons, and verify policy compliance the literal moment the code is written. For example, if an organization mandates specific data encryption or resource tagging, those governance rules are baked directly into the IAC templates. Even if a developer isn't a security specialist, the code ensures compliance automatically. It's brilliant.
But what happens when the worst-case scenario strikes? Say a massive internal change brings your critical business systems grinding to a halt, or an entire cloud provider availability zone just goes offline. If you were doing things manually, you'd be looking at hours, maybe days of frantic troubleshooting. But with IAC, you have instant disaster recovery. Because every step is version controlled, you can just use your Git history to gracefully roll the infrastructure back to a past, known good state in a matter of minutes. Or, alternatively, you could simply change a few parameters in your code to target a totally new region and redeploy an exact copy of your entire infrastructure almost instantly.
So I want to leave you with this provocative question to chew on. Is your infrastructure a liability, or is it code? Continuing to rely on manual configurations, just crossing your fingers and hoping that human error won't bring down your network, turns your infrastructure into a massive liability. By embracing infrastructure as code, you secure your network, ensure consistency, totally eliminate that manual toil, and empower your teams to move at the speed of modern business. Thank you so much for joining me for this explainer. I really hope you found this breakdown helpful, and I highly encourage you to start viewing your infrastructure through the lens of code today. See you next time.